All right, guys, what we're looking at today, and what we're starting today, is Chapter 2. We're starting our chapter over quadratics. So everything in this chapter is going to be dealing with quadratics. Unlike Chapter 1, where it was a little bit of this, a little bit of that, and we kind of jumped around, Chapter 2 is only going to focus on quadratic functions. And mainly, we're going to be looking at the properties of quadratic functions. Chapter 3 will focus on more of the other aspects of quadratic functions, specifically solving. So we'll really start digging into solving in Chapter 3. Now, when we look at the quadratic function here, a times x minus h squared plus k, or we could say a times bx minus h squared plus k, there's a few different things. H and k. H is left and right. We talked about this in the last chapter. Whatever the value of h is tells us how far we move the graph to the left or to the right. And it's kind of the opposite of what we think. Because if we had x plus 3, it's moving to the left 3. If we had x minus 3, it's moving to the right 3. So this h is our movement left or right. Our k value is our up or down. And the nice thing with k being up or down is exactly what it looks like. So if we have plus 3, it's up 3. If it's minus 7, it's down 7. Up and down moves exactly like it should. Our h, left and right, is opposite of what we think. We'll come back to this here in a minute, but those are the main two we have. Now, A is our reflection across the x, our vertical stretch straight. B is our reflection across the y, horizontal stretch straight. Now, before we deal too much with those there, let's just look at our movement left, right, up, down. Horizontal. H tells us the value that we move left or right. And K tells us up, down. And this is here really explaining it, but let's look at this example. So we're given this here, and we want to state how does this graph move? Our x plus 4 squared minus 1. The plus 4 inside the parentheses tells us it moves to the left or to the right. Now the amount that we move is 4. Now the question is it moving left 4 or right 4? It'd be left, because since it's plus 4 inside the parentheses, it's the opposite of what we think. So it would be left 4. The minus 1 is telling us that it's moving up or down. And it would be down since it is negative. Inside the parentheses is the opposite of what we think. So instead of moving it right 4, because it's plus 4, it's moving it to the left 4. And our minus 1 on the outside moves it down 1. Now, you're not going to have to graph these on the homework. But these here are just some nice points on our x squared. Now, if we talked about the movement, this translation, we said it moved left 4, down 1. So this first point here at 0, 0 would go 1, 2, 3, 4, down 1. Here would be its new point. 1, 1 would go 1, 2, 3, 4, down 1, and be right here. Other would 1, 2, 3, 4, down 1. Here, 1, 2, 3, 4, down 1. This one's 1, 2, 3, 4. It gives us an idea of where the graph is. We took the whole graph and moved it left 4 and down 1 to get the new graph. Does that make sense? And that's really all we're talking about, this left, right, up, down. We're just moving the graph, that amount. So every point on this graph is going 40 units to the left and down 1. Questions on this here? We're ready for the next one. So we're given this here. G of x equals x minus 3 squared. How many transformations do we have? 1, the x minus 3, yes? So the x minus 3 inside parentheses tells us we're moving to the left or to the right. And it would indeed be right. How far? 3. Right, 3, because x minus 3 inside the parentheses, opposite of what we think. So our minus 3 is actually moving to the right 3, which means every point on this graph is going to move right 3. So our 0, 0 is now at 0, 3. Our 1, 1 is now at 4, 1. Negative 1, 1 is now at 2, 1. Then we get a graph that looks something like this here. That gives us an idea of how the graph moves, how our solution should look. Questions on this here? Questions on anything we've done so far? We ready for the next one? G of x equals x minus 2 squared minus 2. How many transformations do we have? 2. We have the x minus 2 inside and our negative 2 on the outside. Let's do the minus 2 inside. Inside parentheses is to the left or to the, and how far are we going left or right? 2, and it would be to the right. So we have right 2. And then our minus 2 on the outside would be down 2. And that just tells us the normal function would move right 2 and down 2. So we'd have some function here about. That's not the exact graph, but we get a good picture. Yes? Questions on any of this here? How do we feel about this so far? We're ready for the next one. G of x equals x plus 5 squared plus 1. We have 2 transformations, yes? Which one do we want to look at first? So the inside the parentheses, the x plus 5. The plus 5, the 5 being added to x, tells us that it's going to move the graph to the left or to the right. 5, and it would indeed be to the left. Because plus 5, left 5, opposite of what we think. Plus 1 on the outside would be 1 unit up or down. Since it's positive, it would be up. And that's it. Questions on this here? Last one of this type before we look at the next set. We have x minus 1 squared plus 2. The minus 1 inside the parentheses tells us we're moving left or right. It would be to the right. How far? 1. Our plus 2 on the outside would be up 2. Questions on any of this here? We feel good with this here so far. Now the next thing we're looking at is reflection across the x and y axis. Now again, just like we talked in the previous chapter, when we have that negative, when the sign in front of x is negative, we have a reflection. So if a is negative, it's a reflection across the x-axis. If our value of a is negative, doesn't matter what the number is, if a is negative, it's a reflection across the x. And it has to be outside of those parentheses. If our b is negative, if the sign in front of x is negative inside the parentheses, it's a reflection across the y-axis. if the number where A is, if it is negative, if there's a negative sign where A is, so outside those parentheses, there's a reflection across X. If there's a negative inside the parentheses in front of X, it's across the Y. Yes. Yes. So can we tell that distinction there? So if it's outside the parentheses, it's across the X. If it's inside the parentheses, it's across the Y. Now the one they're showing us here with across the Y ends up graphing it or reflecting it onto itself, so we don't really see any reflection. But there is a reflection across the Y-axis. Now the other thing we have is horizontal stretch and shrink and vertical stretch or shrink. Vertical. So if we're multiplying by a value of A outside, if A is greater than 1, it's a vertical stretch. If 0 is less than A is less than 1, it's a vertical shrink. And these we felt comfortable with, doing vertical stretch or shrink. Vertical stretch if A is greater than 1. Vertical shrink if A is between 0 and 1. These we feel comfortable with. That's a funky way to write that. Okay. Yeah, I didn't think I was going to make that, but all right. Questions on horizontal or vertical stretch or shrink? Now, horizontal stretch or shrink is based off the B value. Now, before we apply it or look at the actual value of the stretch or shrink, if it's stretch or shrink, we have to take that value V and flip it. So if they tell us the value of B is 4, we have to flip it first to 1/4. And 1/4 is between 0 and 1, so it's actually a shrink. And that's going to make a little more sense when we look at it. So let's actually look at some of these here and break them down as we go, because seeing the definition of it and seeing the application of it are a little bit different, because once we see how it works or how it looks, it's going to make a lot more sense than just seeing it written out. So if we look at this first one here, g of x is equal to -1/2 x squared. How many transformations do we have? We have 2. We have the negative and we have the 1/2. They are, even though it's -1/2, those are 2 separate transformations. The negative is a what? Reflection. It's a reflection. When we have a negative in front of that x, being multiplied by that x, it's a reflection across one of 2 axes. It's either across the x or across the y. Yes. Since there are no parentheses, since it's outside the parentheses, it's across the x. So if there's no parentheses, it's understood to be outside. It's across the x-axis. If it's inside parentheses, it's across the y-axis. So the negative is purely about the reflection, especially when we have this multiplication. So the negative x squared negative parentheses x is across the x-axis. Our 1/2 is our stretch shrink. Now, since it's outside parentheses, this would be vertical. Stretch or shrink of 1/2. Yes. Vertical is just what we look at. Since it's between 0 and 1, it is a shrink. If that value outside the parentheses is greater than 1, it would be a vertical stretch. That's it. This here is a reflection across the x-axis and a vertical shrink of 1/2. That's it. Questions on this here? Two x squared plus 1. So we have, again, two transformations. Yes? Let's do the easy one first. Plus 1 tells us what? Up 1. Now the 2 being multiplied inside the parentheses means we're talking about horizontal stretch or shrink, yes? Before we even look at stretch or shrink, we have to flip that value of b. So it says the value of b is 2. If we flip it, that value of b that's being applied to the stretch or shrink becomes what? 1/2, yes? We have to flip it. Horizontal stretch or shrink, we have to flip it. So the value of the horizontal stretch or shrink is not 2, it is 1/2, yes? Okay. Horizontal stretch if b is greater than 1. Is it greater than 1? No. It's between 0 and 1, which tells me that I actually have a horizontal shrink of 1/2. Okay. One thing to say and another thing to see it. Because us just saying that, okay, we can kind of get it. We somewhat wrap our head around it. Sometimes better to see a picture. Horizontal shrink means that this graph that's why. It's going to get skinnier this way. We're going to shrink it along the x. Close it in. Because when we stretched along the y, we pulled it up quicker along the y-axis. If it's shrinking along the x, that means it's not increasing as fast along the x-axis laterally. It's not going faster this way, it's going slower. So those should squeeze in. So let's see here. So y equals x squared. Instead of having 1/4, we'll have 2x squared. And yes, it did. It got skinnier, yes? So we shrank it horizontally. Along the x-axis, it is increasing slower. Which means if it's a fraction, it's going to increase faster than a stretch. Do we see how that 2x is actually a horizontal shrink of 1/2? Let's look at the next one today. Negative 3x squared. Are there any parentheses? No. So that means there is no horizontal stretch or shrink. There is no reflection across the y-axis. There is no left or right. All we have is the negative 3, yes? What does the negative tell us? The negative tells us it's a reflection across the x-axis. And that's purely what the negative tells us. The negative, a part of that negative 3, does do nothing with the vertical stretch or shrink. It's just reflection across the x. Now, since the 3 is outside, it would be a vertical stretch or shrink of 3. Since 3 is greater than 1, it would be a vertical stretch of 3. Questions on this here? Any question on anything we've done so far? Describe the transformation represented by this here. We have 1/4 x squared minus 2. Let's do the nice one first. The minus 2 would indeed be down 2. Now the 1/4 inside parentheses being multiplied by that x tells us it's a horizontal stretch or shrink. But before we can even determine if it's a stretch or shrink, we have to take that 1/4, that value for the horizontal stretch or shrink, and flip it. So what happens when we flip 1/4? We get 4 over 1 or just 4, yes? Questions on that there? Now once we get that 4, we can put it together with our stretch or shrink. So is the 4 greater than 1 or between 0 and 1? Greater, so it'd be a horizontal stretch of 4, which means if we graph this, that x squared, the new one, should be increasing faster along the x. It should be wider than it. And if we graph 1 over 4 x squared, we do get the one in red, which is indeed wider. We stretched it horizontally to get this here. So 1/4 x squared is indeed a horizontal stretch. 4. Questions on this here? Let's look at this one. 1/3 x squared. How many transformations do we have? We just have the one. We have the 1/3. Since it's being multiplied by the x, it's our value b would mean it will be a horizontal stretch or shrink. But before we even figure that out or try to calculate that out, we have to take that 1/3 and flip it. And if we flip it, we get 3. So this would be a horizontal blank of 3, and it would be stretch. Now the only one we have to flip this on is horizontal stretch or shrink. Vertical stretch or shrink, it's exactly what it is. Questions on this here? Interestingly enough, that 3 in front of the parentheses would be vertical stretch or shrink, yes? Is this 3 is a vertical stretch or shrink of 3. We don't have to flip it. Vertical stretch and shrink. We don't have to mess with that 3. That's exactly what it is. And since that 3 is greater than 1, it means it's a vertical stretch of 3. Now we just need to deal with the minus 1 inside the parentheses, which would be right 1. As that x minus 1 is moving it left or right, opposite of what we think, so it would indeed be right 1. Questions on this here? How many transformations do we have here? 3. So what's one of the first ones you see? Yes. So here we do have the negative, and there is the plus 3 and plus 2, yes? Negative outside, negative being multiplied, is a reflection across the x-axis. Since it's a negative outside the parentheses, it's across the x-axis. If it was inside, it would be across the y. Plus 3 inside would be left 3. And lastly, plus 2 outside is up 2. And that's it. Questions on this here? Are you ready for the next one? We'll do those last 3 tomorrow. This is your assignment for this year. 3 through 11 odd, so 3, 5, 7, 9, 11. 17 through 21 odd, and 27 through 29. So it's going to be by the end of the day for chapter 2. Then chapter 1 didn't have an official test, so I'm making it due Friday. Does that make sense? So this is part of chapter 2. So everything we've done up to this point for chapter 1 is due Friday. Chapter 2 is going to be on the chapter 2 test. We will have a chapter 2 test.